Previously we've looked at calculating stationary points of graphs. Now these have been able to fall into three different categories. We've got points of inflection, maximum points and minimum points. Now points of inflection, the graph goes stationary for a few seconds and then continues on the direction it's going. Maximum and minima, the graph hits a high or a low point and turns back on itself. Now the issue with these is they're not the maximum and minimum of the curve necessarily. Sometimes they are, sometimes they aren't. If we think of the x squared curve, that comes down, touches at 0 and goes back. So the minimum value of that curve is at 0, so it's y equal to 0. However, if we think of a cubic, it comes up, hits its maximum turning point, goes down for a minimum, and then shoots back up and goes off to infinity. So there is no set maximum or minimum value there. The maximum and minimum turning points are just highest with respect to each other. What we're going to look at here is, imagine we're now going to close off the interval the graph exists on. So what we're going to do is we're going to limit its values. So we're going to say it only exists between A and B for the case of what we're going to look at now. What we're going to determine is how we can get the maximum and minimum value of the curve within that set region. What we're going to look at is asking ourselves, how do we find the maximum and minimum values for a curve in a set range of numbers, i.e. where it only exists between a set number of values. So if you imagine looking at this first curve, imagine this is just a depiction of f of x. What I've done here is I've limited it between a and b. So a is some negative value of x, b is some positive value of x. So I've limited my curve to only between those two values. Similarly with this one, the only difference is a and b are both positive in this case, but it's still limited between two values. Now the question we're asking ourselves is, how do we determine the maximum and minimum values for these curves within this limit, within this range for x? Well, look at both of these curves. If I look at this curve here, the maximum value, i.e. the highest value, occurs here. It occurs when my curve touches this minimum value of the range, i.e. the value a. If I'm looking at the minimum value, it's there. It's the lowest value the curve takes within that range, and it's this value here at some point x. This value here, yeah, it's a high value, but it's still lower than this one, so it doesn't count. Similarly with this one here. If I look at the second curve for my maximum minimum values, well, my minimum value is actually here again on a. It's at one of my limits. My highest value is up here. I've got a lower value here, yeah, and I've got a value here at b, but neither of these are maximum minimum, i.e. highest or lowest. This is my highest, this is my lowest. What I can then say is that the curve has a maximum minimum value in one of three places. The first one is at A, the second one is at B, and the third one is the turning points. The highest and lowest values for the curve exist in one of these locations. What we've got to do is determine which one it is. Now, when we're doing that, we have to ask ourselves the three questions. What's the value at A? What's the value at B? What's the value at the turning point? All for the y part of the coordinate. Then I'll look and see which is the highest and the lowest. That'll give me the maximum minimum values for my curve in that range. Let me show you what I mean. Imagine I ask the question, find the maximum and minimum values of f of x equals x cubed minus 12x in the interval -1 less than or equal to x less than or equal to 3. Now we said before, the maximum and minimum values can occur in three places. The lowest value of the range, the highest value of the range, or the turning point. So we have to determine the value of f of x at all three of those places. So the first thing it's useful to do is calculate the turning points. So first thing we should do is take the derivative. Derivative of this, take that down, I get 3x squared, take away 12, and to get the turning point, that equals 0. So 3x squared minus 12 equals 0, and I have to solve it. Well, I'll take 3 out as a common factor, x squared minus 4 equals 0. This here's a difference of two squares, so I get 3 bracket x minus 2, x plus 2 equal to 0. That gives me two values for x. This one here gives me x equals 2. This one here gives me x equals -2. Now at this point, we have to compare this with our range. Our range is -1 less than or equal to x less than or equal to 3. This value here, x equals 2, falls within my range. This one doesn't, so I don't have to include this one in my further calculations. If the question asks me beyond this, what are all the turning points? What are the maximum and minimum? Something like that, we do. But for the sake of this question, we don't need to include it. It is out with our range. It has no effect on our final answer. So now I know x equals 2 is one value I'm going to have to look at. I'm also going to have to look at x equals -1 and x equals 3. I can then get the highest and lowest values from that. So first thing I do is f of -1, the lowest part of my range. Substitute it in and find out what I've got. So I get -1 cubed, take away 12 times -1. -1 cubed is -1. 12 times -1 is -12, but it's minus 12, so that becomes plus 12, so that's 11. So my value at f of -1 is 11. I then look at f of 3, so my maximum value, and substitute it in. I've got 3 cubed, take away 12 times 3, well 3 cubed is 27, 12 threes are 36, so it's 27, take away 36. 27 take away 36 is -9. So I've got my value there. The last one I have to look at is my turning point. So where that would occur, which is the x equal to 2. So I substitute that in here and I do f of 2. I get 2 cubed, take away 12 times 2. 2 cubed is 8, so I've got 8 minus 12 twos are 24. 8 take away 24, which is -16. So what I can now say is, right, I've got my maximum and I've got my minimum. This is the highest, this is the lowest. I've then got to communicate it. I've got to say something along the lines of the maximum of 11 occurs at x equal to -1, and the minimum of -16 occurs at x equal to 2. If I don't communicate my answer clearly, I don't get the marks. We've done all the other steps in problem solving. The last step is always going to be communicated. What's the conclusion? What are the reasons for my answer? What am I telling you? That right there is how we communicate for this sort of problem. Here's another example for you. Find the maximum and minimum values of f of x equals 2x minus x squared in the interval -1 less than or equal to x less than or equal to 2. So again, we have to do the same set of steps. We find our derivative because it could exist on the turning points or the two endpoints of our range. We then calculate the values we need to within the range that we're allowed. So let's look at this. Take the derivative. So I get f dashed of x, that equals 2 minus 2x. And to get the value for it, I take that to be x equal to 0. Solving this gives me x equal 1. Well, that is definitely in our range, so I include it. If this was bigger than 2, or if it was less than -1, I wouldn't include it in any calculations. But we still have to check it just to make sure that we do it right. So now I've got that, I know the three values I'm going to calculate. I need to calculate it at -1, 2, and when x equals 1. So I'll do f of -1, substitute it in there. I get 2 times -1, take away -1 squared. So I get -2, take away 1, which is -3. So that's my value at f of -1. F of 2 equals 2 times 2, take away 2 squared. So that's 4, well, take away 4, that's 0. So I know my value at f of 2. The last one I do is the stationary point, the turning point. So I do f of 1. So I do 2 times 1, take away 1 squared. So I've got 2, take away 1, which is 1. So from that, I can read off my maximum and my minimum. My minimum is -3, my maximum is the 1. Now communicate it. So therefore, the maximum of 1 occurs when x equals 1. And the minimum of -3 occurs when x equals -1. So I've got where they occur within my range, and I've got what values they occur at. We have to make sure we do it. We have to make sure we calculate these values correctly and we communicate it. Because remember, it can only happen at one of those three places. Start point, end point, turning point. They're the only places within that range of values our maximum and our minimum value can occur.